welcome back. Good evening, everyone. Welcome back to next part in Numpy, computation and dimensional arrays. So before we have seen what is the n-dimensional array, and we have created a three-dimensional array, and we have seen how it got stacked up. We have already seen which is which we have seen like okay. So yeah, so the one dimension is this, the second dimension, and the three-dimensional. So if two-dimensional arrays are stacked up one on another, it's like a three-dimensional array. We have seen how to get the dimensions like of the array. Now we have seen up to here fourth challenge. Now we will be seeing the remaining part of the session. So now what we will be doing. Okay, so I think we have already seen this non-zero elements where we have used non-zero. So yeah, also I think runtime got disconnected. So I am just rerunning the import statements. And then let me run again. No, it should not be giving it. So we are getting, so we already seen this is the indices of this array. Now let's go to next challenge. So is to NumPy to create a 3 by 3 array with random numbers. So before we have seen arrange we have seen arrange, right? And now we see arrange, it is actually giving a single step of, so for example, if we give arrange, it is like uh, giving like a range function if we have remembered. So it will give certain elements with the step up. So step up by default it will be 1, but if I just change the step up to 2, let's see what it will give. So yeah, so using a step up, but we don't need that one, but we need to create a 3 by 3 three-dimensional array, you can say. So for that, we have already in NumPy to create that function. Yeah, we have in NumPy only there is a random function. So pseudo random number generated. So the same we have used already the random. I mean to say the random module we have used already. So that is actually different from this NumPy module. So we are importing that random from NumPy random. We are importing random and we are just calling a random. It creates this random function will create a 3 by 3 shape, actual three-dimensional array with the shape 3 comma 3 comma 3, like 3 axes, which will having all the 3 elements on all the 3 axes. So even if you see here without import statement, we can call this one. So we are just changing. So what if z comma and dim, just calling dim attribute. So shape is 3 and the dimension number of dimensions is actually 3. So so even the PPT is similar challenges we have. So line space. So line space is again a vector. So the same single vector is nothing but a single dimensional array. So it creates a single dimensional array with some space dot event. So for example, I want num is the elements, number of elements I want. So 0, 1, I'm just counting the elements 1, 2, 3, 4, 5, 6, 7, 8, 9. So depending on the number what we have given, it will actually arrange. So if I just want to 5, let's see how it arranges. So 20, 25, 25, 100. So I just want for 10 how it arranges. So here the shape is, if we are seeing, it's a single dimensional array. So it is like a vector. So start, stop, number. So endpoint, I think the step up also is there. Step option, what you have seen in arrange. Now the another challenge. So yeah, we have did this random. Okay, without import statement, we have seen already line space. We have created one dimensional array. So yeah. So now we should be creating either a 9 values. So already we have done this. So numpy. Okay, I think plot on the chart. So now the same thing. So instead of using line space, create another vector of size 9. So the num would be 9, and the value should be range between -3 to +3. So both included. So in line space, both are included. And the plot x and y on a line chart using matplotlib. So the same thing. So we are using line space start stop equal to. So even if you don't give this also, it will take, we are giving keyword arguments. Here we are giving positional arguments. So now we are, what we are doing, we are plotting, let me, because it should be 9 only. We are plotting two, so yeah, x and y, we are plotting two vectors. We say along x-axis, we have this one like at 100, it is like it is having a positive value. So we have plotted at 100. So if we just reverse this and again plot it, let's see how it. So we have just reversed what is the start and stop value. So now the plot would be reverse. So if you see for 0, it will be at 3. When we are reversed it, actually for 100, it will be -3. So yeah, the plot by default, it is a single line plot. Now we will be using array called noise. So again, we are creating a random using 128 by 28. So what we are saying shape, we have 128 by 128 and 3, so which has random values. So and we are plotting that. So if you see, it is actually a television screen which we used to see in a cathode when there is no cable. Sorry, cable. So we used to get some noise, right, for color television. So black and white, we used to get only black and white dots. So here we have defined 128 by 128. So what if I have defined, for example, 256, just doubling. Yeah, it's a very tiny dots we have seen. So why this is plotting this kind of images like I meant to say dots, which is maximum. It is in red, blue, and green shades. So okay, let's go back to 128 by 128. So let's go. We will be seeing in a while why we are getting this kind of images. So here we have seen although we have got only one line, but when we are just created one array and when we are just plotting only that array, so how it is displayed. So yeah, now next moving to next part. So algebra, so linear algebra with vectors. So here the main thing which differentiate Numpy arrays and Python list is the main thing. This one. So we are creating two arrays, one v1 and v2, and whenever we are doing v1 plus v2, actually it does element wise addition. So the first element, which is at index 0, 0, 0 on v1, and at index 0 on v2, it is actually doing addition. So it's like it is doing vector addition. So because this is not a list, but it is more of a kind of a NumPy array. So the same thing, if I define it as a list, for example, if you see here, it just concatenates. So yeah, if you see here, it is just adding the after 7, it is adding 2, 1, double 3. So it is concatenated. This is the main difference between vectors, like vectors. Vector is nothing but one-dimensional array. Yeah. So this is one of the main difference which we can remember. So the same thing applies for my this also. So if you just try this, so it will be 4 into 2, 5 into 1. So again, it should be index. For example, if I just remove this, and it is like there is no fourth index. So how it behaves? Let's see. So if I just add it, so you will get error because the shapes are not correct. So we can't actually add vectors which are having different shapes. So the shape should be same. Something like that. Just change the value, last value. And here if you just, for example, if I just I'm multiplying list 1 into list 2. So here what we will get error only. Cannot multiply sequence of non-integer type of list because we can't multiply a list, but we can multiply arrays with the vectors. So now, what about scale broadcasting? So, so broadcasting is nothing but when a vector is multiplied with one scalar object. So here, for example, this vector is one-dimensional array, and scalar is nothing but everything just multiplying into. It applies for everything, like whatever it is in the vector, it applies all that. I mean to say, whatever we do the multiplication or operation, I mean to say. Yeah, the operation is applied across all the elements in the vector. So it's like 5 into 2, 10 into 2, 6 into 2. Yeah. So now that's the thing we will see. So here, so we are creating a two-dimensional array. So the broadcasting is will be same across in any dimensional arrays. So for example, so it's like a two-dimensional array. So we call random attribute, and we call shape attribute on this array whatever created. So we are just adding. If you see here, we are for this vector we are adding a 10 scalar. So we are broadcasting. So it applies for across all the elements. So we have added 10 to all the elements. So now if we just multiply, we are multiplying with 5 across all the elements. So then next the interesting part is matrix multiplication. So generally we have learned how matrix multiplication works. The number of columns in the first matrix should be equal to number of rows in the second matrix. So if we see here, it is a 4 by 2 matrix. So number of columns is only the number of columns is only 2, but we have 4. There is a dotted notation actually. Dots are there. So here there are 2 rows, but there are 3 columns. So generally what it does, so whenever we do, so first row into first column. So this, so let's take it's a 2 by 2 matrix, for example. So just let's leave about dot notations. So, but if I see one element, what it does. So here A1, 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 A12. So now first it will be multiplied with A11 with B12 plus. Okay, so if we just again, so A11 it's multiplied with B12 plus A12 is multiplied with B22. Similarly, if I just take A33 example, like C33 this column, so how it will be doing? This is the first element. So A32 element is again this element into this row. So it's like A32 into B13 plus A32 into B23. We have already learned matrix multiplication, so that's the I'm going to say we have learned I think ABCD, so and ABCD, so it's like AD plus BC something like that. We have learned the formula, so just if we just remember that formula, so it's like the same thing. So first uh, element is multiplied with the first element, and the second element is multiplied with the second element for this first row, like this one. And then again for C13, what it will do, this first element, second element is multiplied by B13 plus second element is multiplied by B23 for C13. But again, A3 for C33, so second element is multiplied with this one. So first element is multiplied with this one, first row, like column. First element in a row is multiplied with first element in the column. So A11 with A B2 multiplied plus A11 with B2. So it's a difficult part, right? Just if you want to do matrix multiplication, also for very high level, I mean to say, we can do for single level, but what if we want to do for very high level, like for example, there is a very matrix above size 50 by 20 and the same matrix. So for that kind of easiness, so in NumPy there is actually directly we have matmul, like matmul function is like matrix multiplication function. So we are creating two arrays. So with dimensions, let's see. So we have one, two, three, four rows and two columns. So similarly, we have two rows and three columns. So the final thing will be 4 by 3 matrix. It will come like so 4 by 2. A has 4 rows, 2 columns, and B has 2 rows and 3 columns. So dimensional result will be 4 by 3 just. So how we will be doing? Just simply we are calling matmul function. So if you see the documentation of this, action next to array like, so it will be arrays. So whenever we multiply single dimensional, it will be a scalar, like one dimensional array. So that's what it is saying. Generally, it is the array. So let's multiply. So now when we do that, we are creating a another C array or matrix multiplication. So now matrix C has 4 rows. So instead of calling this also, so there is a at the rate operator which is actually does the matrix multiplication only. So it is again a very handy operation whenever instead of calling this one. So when we call this, it's like a multiplication operator, matrix multiplication operator. So the results will be same. So, so this is like we have matrix multiplications. No, it's like broadcasting different. So whenever we broadcast two-dimensional array with one-dimensional array, the result will be two-dimensional array only. Even the same thing. Whenever we broadcast a three-dimensional array with another three-dimensional array, then it's again a three-dimensional array only. Even when we broadcast three-dimensional array with two-dimensional array, the result will be three-dimensional array. So the same thing is the formula we have created. For example, if we want to check, so this is how we have created. So let's go back and to check. So first row, so C12, like first row, second element, how it is got calculated. So first row, second element is like it will on second column. So it's like 1 into 1 plus 3 into 8. So 1 plus 24, it is like 25. So it should be C1 is 25. Even the first element, so 1 into 4, 4 plus 3 into 5, 15. So 15 plus 4, it is 19. So this is very easy, right? So now let's go to the final part. So the image, manipulating images. So this is very one of the very important topic in an Numpy. So yeah, so images are nothing but a collection of pixels. So each pixel is nothing but other than value of a color. So any color can be represented as combination of red, green, blue. So this is all we know. If not, you should be knowing. So every color is a combination of different values of pixels in RGB spectrum. So red, green, and blue spectrum. So this is how we have done. So yeah. So if you see here, depending on slider, so how the background is changing. So every image is actually this to say combination of red, green, and blue pixels. So let's see how it got represented. So now we have already seen we have already imported from SciPy we have missed and we have imported from Pill we have imported image to read out uh, this one like so we are what we are doing from miscellaneous we are calling face and we are loading it in image variable and then we are just plotting that image variable. So now it is a raccoon actually. So now what is the type data type of image when are we see? So here we have seen it's like an array of different we are not sure how much is like data type is un int 8. So now if I just call the type on that image, it is actually a numpy array. So the every image is a numpy array, and it's a three-dimensional array. So if I just call the shape, so we already seen this. So it's like 768 by 1024 pixels. It's size. So what is the dimension? So it is a three-dimensional array. So it's having three axes. So yeah, first axis having 768 in this one, and third axis having only 3, and second axis having around 1024 elements. So now this is we have this one, so it has each matrix, which makes sense. It's a resolution of the image. So generally, whenever we load an image in Numpy, so it is like resolution. So already I have shown you that uh, uh, what are the resolution. So those are the pixels. So what it got converted into Numpy array. So here what we are doing. So now we will be applying our broadcasting and matrix multiplication here. So to convert our image to black and white image, all we need to use this formula. So we have to apply this formula to all the RGB values, whatever we have. Okay. So generally, this only works whenever it is between 0 to 1, but our currently our values in the image range from 0 to 255. So let's go back and see how our yeah. So we are everything is around 0 to 255 only. So generally, whenever we divided it by 255, it converts to 0 to 1 values. So divide all the values to 255 to convert uh, to sRGBs and multiply array with gray values provided to convert the image to grayscale. And finally, matplotlib and set grayscale to display the result. So let's see one by one. So the values in image range from 0 to 25. So divide all the values to convert. So now what we are doing, first of all, we are creating an array, single dimension array with the formula what I have shown you 0.26. So yeah, so let's keep it aside. So now what we are doing, we are creating another array where we are dividing image with, so it will apply across all the values. Now what we are doing, we are doing a matrix multiplication. So either we can use this one like at the rate, or we can use matrix multiplication. So what we need to do, we are applying across the full axis all the data, like because if I just add a code column, and if I just display this, so now it is everything is under 0.0 to 1 because we have divided it to 55. Now it got. Now what we'll be doing, we are just multiplying to apply the formula. So, so before that, let me see what exactly this image gray turned out into. So I meant to say, yeah, yeah. No, it is just having two-dimensional only. So if you see, because now it got converted into two-dimensional because what happened? Because we multiplied it, so it's like the shape is like three axes, right? So we have three like we have multiplied all this with the array with the three values. Does it? So I just call what is the dimension also. It's a two-dimensional. What we are after. So this is like the formula y linear is equal to 0.26 into r linear plus. This is the formula to convert any image which is having RGB values in the range of 0 to 1. So now when I'm just plotting it out, now we have our scale, but here what we have used C map equal to gray. Otherwise, if we are not using the grayscale, it will be something like this. So which is not required. So let's see how exactly our image looks like. Image gray. And the same thing. So we'll be using the same NDRS. So we have to flip this upside down or rotate the color image. So grayscale upscale down and invert the color image to. Let's see. So the first thing, so we already seen this array one. So just for our reference purpose, so we already seen the flip. So what it is doing, it is just flipping all the values. So the same thing we are just calling np.flip so that it actually inverts. So here from 1 3 it got inverted to 3 1 and it goes to last. So now print A1 and array is rotated. So we can actually rotate A1, rotate 90 degrees is another, uh, I meant to say function or attribute or function from Numpy where we have called our method, you can call it as. So whenever we call the rotate 90, so it actually rotates this data. So it has kept so 3 1 and 1 0 2 6 7 9. So if you carefully observe, it just rotated to 90 degrees. Our matrix it got rotated. So similarly, if we just rotate for side angle, we are rotating image, not grayscale image. Gray. So what we are doing, we are just solar image, nothing but we are just using again broadcasting here, 255 minus image. So we are actually subtracting, we are inverting it. We are inverting all the values in the image so that the color image got inverted. For example, yeah, got inverted. All the pixels got inverted. Just we have did the subtraction. Not the same thing. It is actually sci-fi's image. I meant to say. So whenever you install the sci-fi, so by default it will be available in its folder. So but what if we want to do the same kind of operation on our image? So whatever we image, so we uploaded some macros image. So now we are using a pill because for pill module. So we have imported image and we have opened image file. So now we have what we did. We have converted that image into array, Numpy array, and we have seen. So it is the resolution what we have already shown you. I have shown the last video, the last session. Now the same thing what we do with the same inversion. Yeah. Again, if I just want to flip this image, just taking not image array, image array. So we have just flipped it out. But again, because we have changed this one, the array got impacted. So, but if I just want to flip only this image, let me just reload it again. And then if I just plot this, now if I just plot this flip that image, I should not get inverted. Okay. I'll just run this again. Let me check what it is doing. Okay. 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 Because we have flipped it in the grayscale, we don't find uh, any change in colors. But what if we have flipped our data also, right? Due to which our colors got changed. So grayscale is having only around grayscale image is having only 0 to 1. So yeah, even if you flip, so there won't be any changes only. But whenever we flip it, our color image, so it actually changes all the colors. But again, if we just rotate it, let me check. I think again, let me just want to see. I just want the same thing using uh, not grayscale. I want to see how the image will plot. If I just rotating the color scale image, how it behaves, color image. Yeah, even this got very different texture. So all the colors got inverted. If you see here, so instead of 90 degrees, if you just check, it is total flip. So it got rotated, but even the color got inverted. If you see the main image, yeah, the colors, the green color, if you carefully observe, it's very green. But whenever we invert the main color image, yeah, so the color is itself is different. So I'm just rotating this also. So here again, when we rotate 90 degrees, our colors is not changed, background colors. Yeah. So depending upon our requirement, we have to use different techniques to do all the image analysis. So it is like a negative shade, where it is mainly used this kind of techniques in medical diagnosis or high level scientific diagnosis using image analysis. So Numpy is mainly used at that level. So whenever we have a requirement or we want to do something on our images, so we need to be very careful, and depending on the requirement, we have to use our data, and we have to be very careful whenever we are changing, loading that data into an array and changing that pixels. Yeah, and, yeah, that's it for NumPy. NumPy is very vast. You can just check some documentation around that. But depending on, as we said already, depending on our requirement, you need to know main few basic functionalities, and then if any advanced computation is required, you can just anyways go to NumPy or numpy.org. So this is the official website where we have different high level things. So we have you can go to documentation, reference guide, API reference. It's like so what already has been broadcasting, what exactly broadcasting is, and even in broadcasting, it's very vast. I want to say very vast documentation is available. So depending on your requirements, we can just check. So here they have given a 4 dimensional also results. So it is good to check documentation. So just whatever we have covered the topics, it's very high level, but if you want to check in very detail, so go to this numpy.org. It's very nice documentation available. That's it for today. Thank you.